Ready. Could you tell me about what you've built?
Okay, so we built a digit recognition system. Essentially, the intention is to mimic those that you see at parking lots where you can drive to the front and then see it. The gate literally opens if you already paid.
Okay.
And that's because they have a camera looking at your plate and they already have that in the system. So here we have a UART system. We have a painter that mimics the plate that's supposed to be there, and we currently have the ability to recognize 2 digits. So we've drawn 3 and 4 over here. This painter information is sent through UART to the Pico.
Okay.
And I can just run through and on the display you will see that the digits will be processed and the binarized versions will be shown in the red boxes and the prediction will be shown on the bottom.
Okay.
And the difference is that the 3 and 4, or the digit on top, is just whatever we draw on the pad, and the prediction is when we feed all that information into a neural network that's running on the Pico, the digit that it predicts.
Okay.
So it's not necessarily always going to be the same. There might be mistakes from the neural net, but that's the idea of it.
Okay.
So I've drawn on Painter 3 and 4. And if I send it over, it shows 3 and 4. And
cool.
Additionally, we have a signal or a flag, and so the LED lights up when it recognizes the digits as being the same as an original list. So that would be like the list of plates that have already paid.
Okay.
And so if it recognizes it as being the same as the numbers of the list, and it lights up, and theoretically that would be like a gate opening.
Okay. Okay.
So I kind of wanted to show this diagram real quick because there was a lot of things not implemented. The blue is, and I'll have you guys talk about it.
So actually, our initial idea is doing the bottom one. So we are captured from the camera, which is from the camera sensor over there, and transfer the image through the I2C signal line, and goes to the auto-threading and to the neural network. So we are working for the bottom path for the first 2 weeks, and we just one thing we realized the camera is working on the Windows system, but it's on the Pico. There's kind of like tons of errors over there. So we are working like separately. So I was working on the camera doing the auto thresholding. So for example, if you're using the camera to capture some image, like you are writing on the paper, the image could be interfered with the lightning. So if you are in the dark area, so your histogram will looks like a bunch of the low grayscale values over there. So we cannot do like the fixed thresholding. So that's gonna push everything to one side of the histogram. So ideally, we want to do something like when it captures image like that, and we want to set a threshold and push to the other side, so we can do the binarized. So, but if you have something like that, then you're gonna push everything right to dark.
Okay.
So what I'm doing for implementing this algorithm is to do auto thresholding. So I'm gonna go through the histogram all the way and calculate the average grayscale, and for that value I'm going to spread into 2 areas and do the conversion again.
Okay.
So that works, but we realized that's it's just the camera cannot work on the Pico, and one thing is because of the memory, and the second thing is that the camera is using 2 communications. One is for the I2C that connects through the image sensor to the Pico, and the camera controller is talking with the SPI with that. So after that, couple issues. So we switched to the top part, which is we initialize the second UART and use the UART to transfer the digits using MATLAB, and we use the neural network to build into the training and build into the Pico over here. and the flash over there. And we also try to tune like the 4 digits, but it's just out of memory.
Okay.
Right.
Okay. Sure.
We tried 4 digits and the 3 digits. It's just the when it's got out of memory and the stack overflow, it's just the VGA host rather than gonna be freeze over here.
Okay.
So I guess essentially to summarize, there was I guess a lot of camera issues that we ran into, so we opted out for this approach.
Yeah.
If I guess back to the digit recognition, if we instead send a digit that's not in our so-called plates recognition system,
Right.
the LED won't light up. So if I like try to write something like 37, it'll still predict hopefully correctly, but
Okay.
it goes through the system and sees that.
Did you save it?
I did not save it. Let me save it. So it
So it
doesn't
makes
predict correctly
made a
this
mistake,
time.
but okay.
Yeah.
Sure.
And the LED turns off in this case. But I think that I accidentally just put a dot there. Okay, if I try again. And they like to it's trained on it obviously is trained on how you write it. So if you if some user comes in and they write in a particular way that is not the network hasn't seen before, it's more prone to be wrong.
Right. So like for instance, I crossed my 7s, so it might have
Yeah.
trouble. Yeah.
You can
Very
try,
nice.
You can try. I guess I can cross it like this,
Yeah.
and we'll see what happens. Yeah, I think
Okay.
it's a 3. Which I guess it does
Fair
look
enough.
like a
It does.
3.
Yeah. Yeah. So can I just can I just confirm that I understand the whole
Yeah.
sequence of events here? So in Paint, you're drawing a 2-digit number, and then you have a MATLAB program that communicates that image pixel by pixel through a UART connection over to the Pico.
Yes.
And the Pico, does the binarization happen on the Pico, or does that happen on the PC?
Currently, it happens on the PC.
Okay. So that sort of binary sliced image gets communicated over. The Pico renders the characters that you've drawn, and also through a neural net that you've implemented on the Pico tells you what characters or what digits it thinks that those hand-drawn numbers are.
Correct.
Yes, very cool. And then it checks whether that digit that it's found is in this list of pretend license plates to see
Yes.
if it's one that you recognize or not.
Yep.
Very cool.
And then lights up the LED if it is.
If it is.
Number of plates.
Cool.
Yeah.
Very, very nice.
Yeah, I think there's a lot of other stuff that can be really tuned out. The camera was the really disappointing part. With we essentially had to comb through a lot of registers
Sure.
to and not figure out how it works.
But as a proof of concept, this is very compelling. Yeah.
Yeah. Yeah, it's a proof of concept, and then essentially this is where with the camera, and he was talking about the thresholding algorithm. With cameras, there's so many external environments with lighting and all that stuff. This bitmap is primed so that it's perfect. It's either 1 or 0.
Yeah.
With the camera, you have RGB and you have lighting, exposure, all that stuff. That I don't know what that data looks like, but if that can be, that's why the thresholding algorithm comes in to make it better, and then on top of that, binarize it, so that it would be cool if the original thought was that with that, then you can read in any digit in any lighting. Right. Obviously, there might be limits, but yeah.
Very, very nice. Very cool demo. Thank you, guys.